Hi everyone, my name is David. Today I will demonstrate a custom encryption scheme that I designed called I call it the NOMO Cipher. It is a substitution, transposition, and finally substitution cipher. So it's a product cipher, meaning that it chains multiple classical cryptographic operations together, so that the final output is much stronger than any single operation on its own. So we're gonna look at Java code right here. We imported like basic libraries, arrays, base64 to kind of like show our cipher in like simple way. Then we got random just to randomize. We to get random ints and scanner just take user input so we can show we can make a little demonstration of the cipher later. So let's look at the encryption method. We just get our plain text and our key, and then we convert the plain text in a array of bytes. First, we have the substitution process layer. This shifts each byte using modular addition against our key. Then we got the transposition layer where we use the Sitter Fisher Yates shuffle. So the Fisher Yates shuffle, this is a fast, unbiased algorithm that works backward through the array, picking a random remaining item and swapping them into the current spot in just one pass. We use a seeded version of the shuffle. So by feeding our secret key into the number generator, we force it to make the exact same sequence of swaps every time, and this helps us to ensure that the receiver can perfectly unshuffle the ciphertext later. So yeah, finally we got our second substitution here. This is reverse key sort. Um, this is to ensure maximum confusion. We use a different mathematical operation here. We sort the scrambled bytes against the key, but this time we read the key in reverse order. The result is a highly complex ciphertext. Um, yeah. So here we have our decryption method. We can see that we take an array of bytes. Um, this would be the ciphertext. And the process of decryption is the same as encryption, but in the inverse way. We first reverse the SOR substitution. Then, because we select a random object with the same key, we can generate the exact same sequence of random swaps by applying those swaps in reverse from the bottom up. Um, yep, we perfectly unshuffle the array. Finally, to wrap up this presentation, I want to talk about the security of this cipher. First, the algorithm cannot be broken by pen and paper because this is a 48-bit linear congregational generator, and to unshuffle the array is going to be impossible for a human. Second, that is super resistant to standard cryptanalytics attacks because we use two polyalphabetic substitutions. We saw the first one and the second one after the transposition. Um, and standard frequency analysis are useless. So yeah, it resists also to known plain attacks because even if the interceptor has the plain text and the ciphertext, the transposition layer prevents them from lining up the bytes. So when we combine confusion and diffusion into this what I call NOMO cipher, um, we effectively secure our data. And this concludes my presentation. Thank you for watching.